So I think you'll be really pleased. If you haven't seen the videos of what Ola does on the web, get a chance to see this now in person. So welcome, Ola Rosling.
Thank you. So thank you very much. That was a great introduction, except for one little detail that most of the videos on... One second, I have to check loading. That's a long password. Yeah, most of the videos on YouTube using the Gapminder animating bubble charts. How many of you have seen them? Yeah, okay. So the guy doing that is my father, actually, in most of the videos. His name is Hans Rosling, and I'm Ola Rosling. I'm at google.com. He's at the Gapminder Foundation. And just to not confuse it, I look like this, and my father looks like that. Okay? So there is no confusion from this point on. Okay, I want to start by showing Gapminder visualizations, just to make sure you know what I talk about. And those are our Gapminder's presentations as an example of innovation on public data. That is the things we've done. Then I'm going to move over to how this technology is available today from Google, and also how we're integrating it into search. So let me start by a great moment almost 2 years ago now, when Obama came to Google and I was asked to give a presentation. Today here I have 15 minutes, then I only got 3 minutes. So I'm going to start by showing you what I showed him in 3 minutes. And that's pretty challenging. So let's see if it works. Yes. Actually, I was pretty nervous. I was standing in building 43, if you've been at Google. And there was this huge press team and so on. And then I saw Obama walking towards the door, and he came up to the monitor, and I was just about to start. So I thought the best thing I can do is actually tell him that I'm pretty nervous. So I said, great to meet you. I'm a little bit nervous. And he said, you don't have to be nervous, you know. And then I said, yeah, I'm nervous for the future of our planet. And then he was really interested what I had to show. So I said, look at this thing, you know, it's like a socio-economic world map. It's not geographical. It's comparing other indicators. So on the horizontal axis down here, instead of east and west, we have rich and poor. So it's GDP per capita, basically, down there. And on the vertical axis, we have at the top, healthy, and at the bottom, less healthy. So we have life expectancy. We're comparing money and health. And this is zoomed in now on the rich countries, and this is where US is. It has a very high GDP per capita, but we find countries on lower GDP per capita like Japan with much higher life expectancy. So in Japan, people get 81 years old, even though there is less GDP per capita. And here is Sweden. Isn't it interesting? It's right almost next to Japan, you know. So US is a little bit down there, but if we zoom out to the global picture, so this is all about putting data in context. We can see that, of course, the life expectancy of US is pretty high, comparing now with all countries of the world. The size of the country is the population. That will be China. The color of it are the regions. And now my key takeaways from this presentation. Don't think of countries as being similar if they are in the same geographic region. That's an important notice. These are Asian countries. Sub-Saharan African countries are all over, almost all over the income spectrum. And here you have Latin America, and you see they are blinking. So, of course, US is pretty high. Though we can find countries with 20% of the US GDP per capita having the same life expectancy. So this is how this kind of tool becomes a overview of big pictures that obviously has been missing in the world. So takeaway number one is don't bundle countries together in meaningless group and think that they are similar. Another very common bundling is the rich countries and poor countries. If you look at this distribution, there are countries on all different income levels and on all different health levels. Those groupings that we tend to do all the time just doesn't make sense, so stop doing it. That's a takeaway. The next one is a static image is lying because the world changes. If we go back in time, the world was different. So we go back 100 years, this is what the world looked like. Of course, these are approximate data. There is no one who can know this for sure. Comparing GDP per capita over 200 years is very, very difficult. If you trust this data, it's because you trust Gapminder's work on harmonizing the data. So that's up to you. But, I mean, there is an uncertainty range on all data. So this is the world 200 years ago. Most countries, including US, would be down there. And now, look, the world is changing. It has changed tremendously during the last 200 years. It was standing more or less still for quite some time. And then in 1900, before 1900, it started to move upwards in health, and to the right, countries getting richer. And when you see this complex pattern changing over time, you should become more humble. I mean, in the sense that certain ideologies or conclusions that we walk around thinking are taken for granted. When you see this data, I hope it invokes some kind of humbleness to the complexity of the problem of societies in the world. So this data is collected not only through UN and from US aid money, but also academic institutions, et cetera, et cetera. So Gapminder has spent a lot of time harmonizing data sources to be able to create these visualizations. The tools I'm showing are available on the gapminder.org website. Okay, so I had 3 minutes. I have to keep up my pace. I'm adding a little bit too much details here. So, but then I said, don't be sad. You know, US is not always at the bottom, because the world is multidimensional. You can pick from hundreds and hundreds of indicators on this axis. Let's pick one where US is actually on the top instead. So I picked carbon dioxide emission per capita. And you can see, US is not performing that bad, you know? Of course, this is also a picture that changed over time. So during the last, this is also a very long time series. You can see that I'm running it fast here, but over the last 100 years, this is how the CO2 emission in the world is approximately looking like. Once again, over GDP per capita. And there was my 3 minutes, you know, he said thank you and so on. He had to move on to other exhibits at Google. But when he walked out the door, he turned around and he shouted to me, "Stop yelling about Sweden all the time. No, stop bragging about Sweden all the time." So I will try to, as we move on. Then I would have showed him these other indicators, which are also interesting if I had more time. Say, for example, health economics. So we have health spendings. Let's grab one of those, let random total percent of, oh, there, US is not at the bottom in this one either. It's pretty high up. So now we're looking at health spending, percent of total GDP on the y-axis. And we can see how most other countries that are on the same GDP level has far lower health spending. So you can see that there are lots and lots of indicators. I'm trying to combine things here, intentionally making a point that is interesting, but really the technology as such can be completely independent of the conclusions on the data. So I say we have 3 layers. There is the data, there is the technology visualizing it, and then are the stories and the findings on it. Those things should be completely decoupled, I think, in the next generation of data. Let's see where I am. This was my, yes. Okay, so Gapminder started off as a, basically we got this idea back in '98. And I called my father and said, I need a computer, you know, because we have this computer program we could develop. And he didn't lend us the money back then. We didn't have anything. So I went to a tax-funded Swedish computer center in Gothenburg, where we sat and developed the first prototype. And then we could get grants from the Swedish aid agency. And we got data from WHO back then. And we were able to create the first prototype. That whole process took like 2 years or something. The data back then wasn't available as easily as it is today, so a lot of things have actually changed. This is why this kind of innovation is I hope to see within the next 10 or 20 years, like hundreds and hundreds of new ways to visualize data. If we can cut the cost of actually retrieving the data and harmonizing it, there will be even more innovation like this. So Gapminder kept adding data to the tool and telling stories with it while we moved to California to develop a scalable version of it, which is called the motion chart. And now I want to show you how this is actually available on Google spreadsheets. So if you create a spreadsheet at Google, you can create columns like this, saying the first column is whatever gonna be your bubble. In this case, it's actually US states instead. So the states over, this is random indicators, unemployment rate, housing price index. And this allows anyone to create this kind of visualizations. It requires long, consistent time series and multiple metrics, so it's pretty unique in that sense. Not all data fits in it. We also added a little bar chart feature, and we keep improving this technology. You can embed this in your web page or just share it with whoever has access to this spreadsheet as well. So we recently saw this ending up on a governmental page, the IT dashboard. They use a slightly different version of it, which is programmatically available in the visualization API from Google, which you can find. I hope I have some kind of screenshot. Yeah, here's the visualization API. So if you search for motion chart or visualization API, you will find these resources. So what about US statistics? Let's move back and see. Gapminder recently did this data set, which combines country data with US states. So the red bubbles in this one are actually the different US states. For example, you have California down there. On the x-axis, we have income per person, so rich is to the right and poor to the left. On this axis now we have infant mortality rate, so we can see how many children die before age 1. Congo is up on 129. We have Mississippi on 11, just next to Oman. We have South Carolina next to Bahrain. This is an interesting cross-data set comparison that is enabled through the integration of data. This picture also changes. Let's go back in time 100 years, and we can see the US states from 1930. Of course, comparing income across these time ranges is very difficult. So don't rely on the data as being exact. There is always an uncertainty. But let's play this over time and see how the red bubbles move over time next to the countries. Here we have data for most countries, and we can see how the red bubbles kind of stop and go to the right. You see? There, the US states were actually in the middle of the crowd among the rich countries, but then suddenly they moved up. And today, this is the latest data. We are right now in Washington, D.C., which happens to be an extreme outlier, of course, a very small population. But in the rich world, it's an extreme outlier where you have infant mortality rate on 14. There's almost no other place in the rich world where you can find that. At least not on country aggregate level. Of course, if you break these down as well. So you can see how the data integration problem would allow us to have this kind of visual interfaces to data. If Japanese and UK data was also instantly comparable, a lot of new insights could happen, and very, very interesting comparisons. So the thing that makes US very unique is there are two things with public statistics in US. One is that the data is pretty available for free by law. The second one is that there is no centralized Bureau of Statistics. Most other countries, like the majority, has a centralized Bureau of Statistics. It's just missing in US for historical reasons. So basically what data.gov is trying to do, from my understanding, is like covering up for this lack of centralization, just to allow you to at least find the data in one place, which of course is excellent. So there is still a lot of harmonization though across the sources. You can imagine comparing education on one axis and health on the other axis. Who is going to harmonize the education and the health data to allow this kind of comparisons? Currently that is not done by the government. It's done by commercial sector, which develops a business model around cleaning up of public data. That sounds like a typical US story. The problem is that this data is then being sold, and it's very hard to democratize the access to these clean data sets. So the cost of cleaning up the data is enormous. I think really the government should take that cost, because that allows students and others to access clean, huge, well-harmonized data sets instead of getting like bulk files of completely different formats from different sources. But still, putting them in one place like data.gov is doing right now, I think it's excellent. At least that reduced the time it takes to even find the data sets. So that's a very good starting point. So what about finding the data? Many people would start on Google. So let me give you a quick look at how we now brought this into integrating it in search. So if I search for unemployment rate in, let's do Alaska, I can instantly get this data. So this is a project that I'm managing at Google right now, where we pull data from Bureau of Labor Statistics and surface it as at the top. This is the not seasonally adjusted, and we're going to improve this user experience by adding more data and more features to it. Right now, we're looking at how people are using it, and I really want to tell everybody who has public data that could go into this kind of system. Please click at the link at the bottom of the page saying information for publishers, and fill out the form, and we can start collaborating. We want to develop this feature in collaboration with you so that we don't come with a ready-built solution and the data doesn't fit. So we're going to integrate more and more data, and as we integrate it, we need to build features that accomplish the needs of each and every data set. This allows you to do cross-comparisons. So, for example, you can put a county of Alaska, and you see the seasonality is actually really interesting, and compare it also with the US total. This allows you to then link to this or embed it in your web page. And we're looking at how people are using this right now to imagine a new service where you search and you find authoritative data, probably multiple sources in many cases. You pick one of them, you embed it in your website, and we're going to keep the data up to date. We're going to keep the latency down. This is very difficult things to do, so this chart needs to load in less than a second, and we take care of that part as long as we get access to the bulk files. That's kind of the model. Now people could see visually far more data far more often, and I think that's going to build up a literacy for statistics, which is just not there today in the world. So imagine students growing up with data being used in documents and so on, always with a track back to the original source. There need to be you need to be able to go back to this kind of tool where you can explore explore outside the context, and then also at the bottom it says data source US Bureau of Labor Statistics. You click this one, you end up on the official provider. And this is where, if you doubt what Google did with the data, this is where you control it. So we're depending on the original source to also, of course, provide the data and making it possible to compare it, because we don't want to be fiddling with any of the data. We just basically want to be a layer in between the average users or journalists or teachers and so on. So you can also try this with population searches, for example. If you do population, yeah, I think I'm running out of time. Let's skip that one. Population Louisiana would also work, and you can compare that as it has a jump in the middle of it. So let's go over to Government 3.0. Imagine some years from now, what are we going to meet and talk about? I think in the space of public statistics, there is the risk that we're going to be sitting here and talk about the trust or the cookies. So I'm going to speed up now. So because the trust, the fact that there is an official source and we track it is extremely important. I just want to show, go to the public policy blog of Google to check out more things. This is a picture I drew some 6 years ago or so, saying that the data should live in these brown boxes, trustworthy data sources with a label on it. This comes from here. On top of that, we can flourish lots of different flowers, and it's going to surface to the public. This ecosystem will take time to develop, because the current models of publishing the data needs to change, but there is a trust relation between the users and those providers that will take time to develop. So the nasty picture that I did to illustrate the problem of the so-called database hugging disorder in the public sector, I did this to communicate to my fellow Googlers, why is it so hard for public agencies to release their data set? Well, they spent 10 years developing them, and they love it. This is actually me and my second son, but I replaced it with this silo that they sit and hug, you know. But releasing those silos is tricky, because they don't want to give away their baby. So the thing is that we need to solve this problem in a real way, not just claiming that every data should be freely available. I think that's not realistic. In some cases, it is very, very sensitive, and you need to get the data right to make sense. So, but the problem here is that you can actually copy this baby, and that's so beautiful, because you can make multiple babies. So you can keep one copy of the database yourself, still give away the other ones to the world. So I would say priority for public sector should be in this order. take your database, put up a bulk file, and let people download it. Then start thinking about an API, because it's going to be a nightmare for you when you get traffic to have an API to serve the data. Many public agencies cannot really afford that kind of traffic and to scale it up. Third, from our perspective, would of course be the user interface that is customized for the particular data set. Often, agencies prioritize this in the reverse order. It's also because the UI is so fun to develop and the API is more challenging for the engineers. Bulk files is pretty boring. You serialize it into a text file and put it up. So let's give some cred to the people who actually already did this. You have this enormous a set of data for international comparison from the DHS, funded by US tax money, freely available bulk files used by all the UN agencies and research among the development in the poor world. This has been going on for years and years. This is excellent. BLS has a wonderful page. I can look at these for hours and just start crying. It's so beautiful. Look. Look how beautiful it is. Because I can innovate on top of it, you see? So I can put flowers there. And this is the European. In Europe, actually, the bulk files are standardized across the different domains, so this is even better, you know? So let's do this as the last slide. Read at the top here. It says, index of stat.ref download everybody. Isn't it beautiful? And then the files are called data and readme, you know? Yes, you lose control, but you're going to have your website where you actually have the original number. Thank you very much.
Thanks very much. Get the cookie.